In this video, we are going to look at what happens when we apply a force to a spring. So let's start by looking at the equipment. We need a spring, a clamp stand, boss, a 30 centimeter rule, and a few 100-gram masses. Here we have a hanging spring, and we are going to add mass to the spring and measure how far spring stretches. Spring stretches because a force is acting on it. We also need a worksheet to record our results and plot the graph at the end of the experiment. If you don't have one, your teacher may pause this video so you can draw this table on your exercise book. As you can see on this table, we are using 5 times 100 gram masses, and on the next column we have converted grams in Newton for you. By watching the video, you can copy each results on your table as we write and calculate yourself the extension of the spring using the formula. Extension is equal to length of the spring take away start length of the spring with nothing on it. Before we start the experiment, we should always do a risk assessment, and we have realized we should wear goggles because spring has been known to go flying sometimes. It is really important we protect our eyes. Let's start the experiment. First step, measure using a meter ruler the length of the spring with nothing attached to it and record on the table. Step 2. Now add a 100 gram mass onto the spring, which is equal to 1 Newton. Measure and record the length of the spring on your table. Add another 100 gram mass onto the spring. Again measure and record the length of the spring. This time is 200 gram, which is equal to 2 Newton. We repeat the above step 3 more times by adding 100 gram mass till the total mass on the spring is equal to 5 Newton, which is equal to 500 gram. Using a ruler, we measure and record the length. Hooke's law says if you apply a force to a spring, then the force stretches the spring, and if you don't stretch too much, Hooke's law says the amount of force you apply is proportional to the stretch. So that means if you apply twice the force, you get twice the stretch, and if you apply 3 times the force, you get 3 times the stretch. That works until you stretch the spring too much. Now we have done our experiment and recorded results onto our table. We now need to calculate the extension of the spring by using an equation, which is extension is equal to length of the spring take away start length of the spring with no mass attached on it. We will do the first 3 calculations for you to see and leave the rest for you to calculate using the equation. First length of the spring with no mass attached on it is 2 centimeter. So mass is 0 gram, force is 0 Newton, and the extension of the spring should be 0. Second length of the spring is 6 centimeter. We added the mass of 100 gram, which is a force of 1 Newton, and the extension of the spring should be 6 take away 2, which is the start length with no mass attached on it, and the extension of the spring now is 4 centimeter. Third length of the spring is 10 centimeter. We have a mass of 200 gram, which is a force of 2 Newton, and the extension of the spring should be 10 take away 2, which is equal to 8 centimeter. Your teacher may pause this video so you can do your own calculation and plot your data onto the graph paper and come back to the video to see the completed table and the graph. Once you have completed your results table and plotted the graph, it should look like this. Before we end this video, we will show you what happens when we overstretch the spring. If you overstretch the spring, it won't come back to its original shape and its original length. This is because the spring is made of lots of molecules that are stuck together with their own little forces between them, and when you overstretch the spring, you can break those bonds and they don't come back when you let go. So spring doesn't come back to its original length. So Hooke's law only applies if you keep all those bonds between the molecules together.